Hello everyone. In this video, we will be discussing some more questions on data science. So let's dive into it. First question: how unstructured data is transformed into a format suitable for a machine learning model? Importance of legal classification in grievance redressals. How TF, IDF, or word embedding can be used to extract features from complaint text. So for this, the answer is unstructured data such as text, image, or videos must be converted into structured numerical format for machine learning. These steps include text cleaning, removing irrelevant characters like punctuations, HTML text, etc. Convert text to lowercase, tokenization, split text into individual words or tokens, stop word removal, removes common words like the, is, etc., which do not add significance meaning. Laminization or steaming reduce word to their root forms like running to run. Feature extraction use techniques like TF-IDF, which converts into spare numerical vectors weighted by terms importance, and or word embedding dense vector representation. So and then structure format represent data as numerical vectors or array for machine learning algorithms. Now, legal classification plays a crucial role in grievance redressal by streamlining processes, automates categorization of complaints into appropriate legal categories like example IPC sections, improved accuracy reduces human error in classifying complaints. Fast resolution prioritize the roots complaint to the correct department, ensures fairness, improves consistency, handling of grievances, enhance scalability. It can handle a large volume of complaint effectively. What are the function of TFT, TFID? Purpose. It identifies important words in the complaint by assigning weights based on their frequency in the document and rarity across the crops. Example for the complaint thief of my mobile phone, which we discussed in the previous two videos. TFDI highlight is thief and mobile as important terms. Word embeddings. Purpose of word embedding are maps words into dense vector capturing semantic relationship. Example words like theft and robbery will have similar embeddings, allow model to generalize better. Both method helps in transforming complaint text into format suitable for machine learning classifications. Now we move to the question number two, which is life cycle of a data science project. So we have divided this into the four categories. The first one is stage. The next we have objective of the stage, then key details yet or task, and then tools and or library. So stage one, define the problem. The objective is clearly understand and define the business problem or research objective. Key details or tasks are problem statement, expected outcomes, and scope of the of the project. Tools or a library. Here we don't require any tools or library. We just want to specify the problem discussions. Stage two is data collection. Its objective is to gather data from relevant sources. Key details are collect structured, semi-structured, or unstructured data. Tools are SQL APIs, web scraping, Python, Pandas library. Third stage is data exploitation and pre-processing. Analyze and clean data to make it usable for modeling. Key details are handling missing values, outletting detections, and exploratory analysis. Tools we can use are Python's libraries like Pandas, Matplot, Seaborn, R. Fourth stage is feature engineering. Its objective is to select or create features to improve model performance. Feature selection, abstraction, and transformation. Tools use can be used are Python libraries like sklearn or future tools. Now the next fifth stage is model selection and building. Objective for this is choose and building machine learning models based on the problem. Key details or tasks are select algorithms, train models, and tune hyperparameters. Tools or library we have are Python, sklearn, and TensorFlow, and PyTorch are the libraries used can be used. 60 is model evaluation. Its objective is to access the model's performance on unseen data. Key details or tasks are use metrics like accuracy, precision, recall, and F1 score, which we have covered in our previous videos. That what are their properties and working. So yeah, you can refer that videos too. So tools we require for model evaluation are Python's library like sklearn and matplotlib. Seventh stage is model development. Deploy the model into a production environment for real life world use. Key details or tasks is are use APIs, cloud services, or edge devices for deployment. Tools and library used are Flask, Fast API, AWS, Docker are mostly used. Each stage is monitoring and maintenance. Monitoring its objective is to monitor the deployed model performance and update as necessary. Track drift, retain models, and handle feedback loops are its key details or tasks. Library and tools are Prometheus, Grafana, Python scripts. Ninth stage is communication and reporting. Its objective is to share findings and insights with stakeholders. Its tasks and key details are create visualizations like dashboard and report, and the tools or libraries we can use are Tableau, Power BI, Python, Matplot, or Seaborn. This table covers all the essential stages of data science project lifecycle and can be adapted based on specific nature of the project and its requirements. Let us know if you need further elaboration on this on the comment section. Explain the role of text mining in automating grievance retrieval system, like the key steps involved in pre-processing unstructured text data. So, a role of text mining in automating grievance retrieval system. Text mining automates grievance retrieval system by extracting meaningful information from unstructured data like complaints or feedback. Just how it contributes. Automated categorization. Text mining classifies complaint into predefined categories. Example, service issue, theft, etc. without manual intervention, helping route them to find the right department quickly. Semantic analysis identifies the tone of the complaint, positive, negative, neutral, enabling, em- enabling prioritization of urgent or higher priority issues. Third is effective query handling. automatically identifies key information. Example, complaint type, location, issue to resolve queries or trigger appropriate action. Pattern recognition detects trends or recursion issues, help to improve services or resolve frequent grievances. Improve accuracy, reduce human error in interpreting or classifying complaints, ensuring consistent response and effective problem solving. Key steps involved in pre-processing unstructured data. They are text cleaning, remove unnecessary characters, punctuations, and special symbols, and converting text to lower keys. Tokenization, splitting text into individual words or tokens for further analysis. Removing stop words like the, is, that do not contribute significant meaning. Stemming or lemmanization, reduce words to their root forms. Vectorization converts text into a numerical format using methods like TF-IFT or word embedding. Example, word to VC to prepare data for machine learning models. These steps are essential for transforming raw, unstructured complaint data into a clean, structured format suitable for automated processing, classification, and response generation. Now we move further for the next question, which is explain the key difference between k-mean clustering and hierarchical clustering algorithms. What are the advantages of hierarchical clustering over k-means when visualization clustering relationship? So the key difference between k-mean clustering and hierarchical clustering are we have divided the blocks into three categories: features, then k-mean clustering, then hierarchical clustering. So clustering approach in k-mean clustering is centroid based partitioning, and hierarchical uses agglomerate bottom up or divisive top down approach for clustering. Number of clusters, the k-mean clusters is predefined and there is no specific number of clusters upfront in hierarchical clustering. Cluster shape works best with the spherical clusters. It is for k-mean clustering, and hierarchical clustering can handle arbitrarily shaped clusters. Output: the k-mean clustering outputs flat partition of data into k clusters. Hierarchical clustering dendrums tree structure showing cluster hierarchy. Computational complexity: the complexity depends on the k and its iteration in k-mean clustering, and more complexity expensive is the hierarchical clustering. Initialization sensitive to initial centered selection. No initial section is required in hierarchical clustering. Handling outliers. K-mean clustering are sensitive to outliers. Hierarchical clustering are more robust to outliers. Scalability. Uh, K-mean clustering are better for large datasets, and hierarchical clustering are not ideal for the very large datasets. Cluster relationships does not provide information on cluster hierarchy, shows relationship clusters in the form of a diagram. Now, advantages of hierarchical clustering over k-means and visualization clustering relationships. Dendrogram representation. Hierarchical clustering produces a dendrogram which visually shows the hierarchical structure of clusters. This shows you to understand how clusters relate to each other at different levels of regionality, which is not possible with k-means. No need to predefine clusters. Unlikely k-means, which requires number of clusters k to be predefined. Hierarchical clustering allows the user to decide number of clusters at any level by cutting the dendrogram. Better insights into cluster relationships. Hierarchical clusters give a clearer view of how clusters are nested with each other, providing a deeper understanding of the similarities and difference between clusters. Flexibility and arbitrary cluster shapes. Hierarchical clusters can handle complex shapes of clusters like k-means, which assumes clusters are spherical. This flexibility allows hierarchical clustering to represent real-world data more accurately. Now, for the conclusion, hierarchical clustering excels in providing a visual and intuitive representation of how clusters are related, which can be particularly used in understanding the structures of data. K-means, while on the other side are effective on large datasets, but does not offer this level of insights into cluster relationships. So next question is analyze the impact of data pre-processing techniques, example stopwatch removal, stemming on performance on model performance, and access the system's performance using metrics such as precision, recall, and F1 score. So impact of data preprocessing techniques on model performance are first stopword removal. The impact of the stopword word removal is removes all the common or low informative words like is the that do not contribute to the model's learning. This reduces noise in the data and speeds up the training by shrinking the vocabulary size. Effect of stopword removal is improves model performance by focusing on meaningful words. However, it excessively remove may result in loss of content. It improves the performance of the model, but somewhere it can lose the content also. So next step is stemming. Its impact is reduce words to their root forms, like running to run. This helps group related words together and treating them as a same feature. Effect of performance is simplifies vocabulary, reduces sparsing in data, and improves generalization. However, stamping may lead to ungeneralized like better to bet, affecting semantic understanding. Lemmanization impact. Its impact is similar to stemming by considering the grammatical meaning of words, resulting in more accurate root forms. As we know, the example running as run was to be. Its effect on performance is that more precise than the stemming, lead to better content preservation and improved model interpretation. Next step is noise removal. It is removal of punctuation and special characters. Its impact is eliminates irrelevant information to focus on useful features. Effect on performance is reduced dimensionality and improves model robustment. Now, the performance assessment using metrics are precision. Uh, the definition for precision is proportion of correct predicted predicted positive observation to total predicted positive observation. Here, I had added the formula for the precision, so you can apply this formula on your models, data models. The use case of the precision is its evaluate accuracy of positive precisions. crucial in scenarios like spamming detection or medical diagnosis. The second, we have the recall. Its definition is proportion of correct predicted positive observations to all actual positive observations. So here I have added the formula for the recall. It's true positives plus false negatives, and that's on the formula. Its use case is critical when missing positive instances is costly. Example, fraud detections. Next in we have F1 score. Its definition is it harmonic mean of precision and recall, balancing both metrics. It just balances both of the metrics, precision and recall. Here I have added the formula. If you want to use, you can use it. And its use case is it is used when there is a trade-off between precision and recall, ensuring balance in performance evolution. There are some more additional metrics which are accuracy. Accuracy metrics calculates the overall connectedness but can be misleading in imbalanced datasets. ROC AUC measures the trade-off between two positive and false positive rates across the thresholds. Thank you so much for joining me in this video. Hope you would understand all the questions. And if you have any query, you can ask me in the comment section.